Aloha, Richard Halverson here. This is ITS148. And today is February 10th. Let me share my screen. And we are like around here, modules. Let's see, exceptions. I think the last video was like chapter 8 or something. I think I started to make another video, but I got messed up, so I never posted it up. So let's see where that is. Okay, so the last video was in chapter 8, and I think I might have done one of these. Then we go to chapter 10 and talk about exceptions. And exceptions are just they're ways of handling when certain errors occur in your program. And instead of the program bombing, back in the old days, the program would just bomb. But now you can catch certain bombs and sort of handle them and then recover and continue on with your program. And that's what exceptions are for. One common hardware exception is if you try to divide by 0. If you try to divide by 0, then the resulting number is too big for it to be represented. It's infinity. And so that causes the hardware. That exception actually occurs in the hardware. And the hardware interrupts and sends a signal up to the operating system, which passes it all the way up to you. And if you want to capture that and output an error, it's probably because of some input. Then that's what exceptions are for. And so that talks about that in here. And to be honest with you, this thing explains it very well. I can't do much better than this. You take the code that would normally execute and you place it inside a try except statement, and there's a try block and an except block. And what happens is that if everything goes fine, then the try block just executes and then it skips out and continues on. But if something happens inside the try block that causes an error, like for example dividing by 0, then everything stops in the try block. It jumps into the except block, and then that executes. And then it's able to drop down here and continue on. So instead of the program just bombing, it actually jumps out and executes this except part, and then it continues on. Okay, so and that's called exception handling. And so this explains that. And there are different kinds of errors that are named already by the Python execution machine. One of these are some examples where if you're reading a file and you're at the end of the file, but you try to execute another read, there's nothing there. So that raises an error. It raises an exception. If you are searching a dictionary and you ask for the value for a key that doesn't exist, that can cause your program to bomb. Instead, you can capture the key error and do something about it and say something's wrong and then just continue on. This is the divide by 0 error. There's other kinds of errors, like a value error is where probably if you're trying to convert something into an integer and it's not it's not a digit, you know, it's not a number, it's a letter. That would be a value error. An index error would be is if you're trying to access, let's say you have a list and there's 10 elements in the list and you try to access element number 12, okay, index out of bounds. Normally your program would just bomb, but instead you can capture that error. Maybe I'll put an error message and then just continue on. So that's what that's all about. And you can have multiple exception handlers, as they say. Why not? If it's a divide by zero error, you output this kind of error. If it's a key error, you output some other kind of error, you know, and so on. So that's what this shows you how to do. And I'm not spending a whole lot of time on this because it's the kind of thing where in future assignments, I will ask you to put in an exception handler for a particular condition, and then you know you'll learn then by example. But this talks about you know, various cases. You can the programmer can raise these errors. You know, the programmer can perhaps detect a value error and raise that, and then they then can like behave like it was a hardware error that was raised. So if you have something that's processing some input down in some method, and you want just to take care of all of the kinds of errors that can occur down in that method, then you can, you know, define certain additional types of value errors. I think you can even define your own kinds of errors. All right, so this talks about when you have exceptions inside functions. It's not that big a deal. There's a finally clause to the try except. I'm not really sure what the difference is between that and just continuing on, but there's probably some subtle difference. Here's custom exception types, and I guess can you name? Oh yes, it looks like you can name your own exceptions. So like value error or divide by zero error, you can like name your own. Exceptions with lists. An index error is a common error when it comes to lists. This is optional, right? Oh, this is a lab. It's an optional lab, and it's excuse me. It's where the program asks the user for where's that? Oh, here. The program asks the user. Oh, yeah, okay. The program. Oh, I guess I must have done this one. Well, what does the default template look like? The program asks the user for an index, and then this thing outputs the index. But if the index is out of range, then it outputs an error, but doesn't bomb. Okay, and so after you get the input, let's see. Let me see what the solution was for that. So you input something, and then normally you would just print it out. So I'm going to do that. Print. Names index. Okay, so if it's just this, then if you say print like like index 1, that's going to be Eden. So if I print this, if I run this, it outputs Eden. If I do, you know, -2, I would do -2, it's going to go this guy. So I can do up to let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if I do 10, then that's out of range. 10. Okay, run the program, and boom, it bombs. You get this traceback thing. Whenever you see the traceback thing, that means that the program bombed. And I don't spend enough time talking to you about how to interpret that, because really this tells you almost the entire error. Okay, so, and I get a lot of you know, if you have problems with your code, you can just paste it into an email and send it to me and ask, you know, and ask me what's wrong with it. So a lot of you do that, and so what I'll do, or you'll take a screenshot of this traceback thing and send that to me and say, I don't, you know, this is what I get. Well, that's a fine thing to do, because then I will look in the traceback and I will tell you from what it says in the traceback what the problem is. And so I should do a lot more of that, because, okay, so what this says is there's an index error. And look, this is these exceptions that we've been talking about. There it is right there. The list index is out of range. What do you mean? Well, there's this list here, and you index the list, and a valid range is 0 through 9, but I tried to do 10. Well, there is no 10. So it was trying to execute this statement on line 5. You see right where it is. It's right on line 5 in this file. And if it was in some other file, some module, which we're going to talk about soon, then it would say that. Well, it would be a nesting thing. But anyway, so what we want to do is capture this and not have it say bam, bam, traceback. We want to say gently, you know, please enter in an index that's valid or something. Okay, so we want to put this inside of a try except. In Python, it's called try except. In C# it's called try catch. Every language is different. All right, so I'm going to say try. Then I'm going to say try that. And the exception is going to be except. And I'm going to and I'm going to be looking for this index error. If I get the index error, it's going to return an object, and in the object there's going to be an error message. So that object is going to be called, I'm going to say, error obj, because it's an error object. And so if I do get this, no, I think I got to do as. Yeah. And if I do get that, I'm going to say print. Please enter an index between. Oh, I got a great idea. How about between 0 and length of names. That work? I think that'll work. Oh, and I also want to print out that with this ER. What is it? What is ERR? OBJ. Can I just print that out like that? Let's see. And then I'm going to say Oh, okay, I'm going to do this. I'm just going to do this. Well, okay. All right, I'm going to do this and see what this does. Okay, now when I run this, it says, enter an index between 0 and 10. Ooh, shouldn't be 10. It should be 10 minus 1. Can I do that? Will that work? Yeah, okay. Oh, and then this is the error message. Okay, so I better say that. Okay, so anyway, by the way, that's not going to work for this because you want it to say this: exception, list index out of range. So you want to say exception. This is all you want to say. The solution. The solution is not right. Error, exception, list index out of range. Okay. So I'm just going to print that. Okay. But then otherwise, I'm supposed to give the closest if the first element in the list is invalid. Oh no. Oh, output the first element in the list if the invalid index is negative, or output the last element if the index is positive. So in other words, 10, what 10 should do, as should 12, as should anything, anything. When I run this, it should say that, but then it should also say the closest name is Johnny, okay? Because that's the closest one to output the last element if the invalid index is positive, okay? And -2, yeah, -2 is correct. Yeah, because -2 is this one. Oh, -15. So -15 should print out that, but then it should say the closest name is Riley because it's that one. So to do that, I'm going to say if index is less than 0, then print the closest name is : names 0. Else print the closest name is names, length of names -1. Okay. Let's see what this says. that looks like that. If I do 12, Riley. All right. So this is I don't get points for this, but let's click on submit mode and see what this looks like. All right, so I have to say print. What do I have to say? Name colon space. Name colon that, and it'll automatically put a space. Okay, there we go. All right. So you can see that what normally if we didn't have the try catch, or try except, we would just have this. We wouldn't have any of this other stuff. We wouldn't have the closest name is, the closest name is. We wouldn't have that. We would just have the program bombing. Okay, and this is a way to make it more, user friendly. All right, that's what exceptions are for. And the next one here is where I think you're going to add in your own exception. Like if somebody enters in a negative step count, you want to tell them that oh no, you can't enter in a negative step count. You have to. All right. So here, if somebody enters in there, it's going to output this. All right. So let's go to chapter. All right, and if you have problems with the actual assigned ones, like 9 and 10, then why don't you ask? Okay. But first, I'm going to let you try to do. First, I'm just going to let you try to do them. And so I want to get through modules. Oops. I want to get through modules so you understand how modules work, which you probably already do, but I want to get through this because it's important for when we start our assignments on the different platforms. When you submit them, you have to follow the rules of modules, because to grade your submissions, I'm going to import your submissions as modules into my test programs, and so it's a good idea for you to understand kind of what's going on here. And so modules are very important, and they're handled very nicely in Python. And what it is you can take any program that anybody's ever written, and the methods that are in that program, with the defs up here, you can just import with an import statement up at the top. You just import their program into your program, and then all of their modules, their functions and methods are available to your program. And so that's what this talks about. So we have script one. We have script one, and it's got this function and this function, and then a bunch of stuff using it. And we have script two that's got this function and this function and a bunch of stuff that's using it. And you see, so it's redundant. We don't need to do it that way. Instead, we can have one file that's got this in it, the functions in it, and then we import that. And this funcs.py, that's what this is, except for it doesn't have the py. So you say import, you know, this doesn't have the py, but it's in the same folder or directory as your main program. It's in the same directory. Then you can just do this, and then you can use this fct function and this sq function in this program. And so here you prefix it with the module name to get at the function, or you can do it a different way, and you can just use it by name. If you say from funcs import fct, if you have that up there, then you can just use fct down there. I think we'll see that in a moment. And actually, okay. All right, so here we are. We're importing these two modules, this module and this module. And both of these modules must use system modules, or they come from system modules. So anyway, this just says where they come from. All right. So here, this is the name, this is the file name. And inside this file, there's this function here. And so we want to use this function inside this program down here. And so we say import the file name without the .py. And then we're just able to use it down here. We're able to use this factorial function down here. So let's do this one so we see what it is. Okay, so this is arithmetic.py, and all it does is define this calculate function. And this is main.py. Okay, so all we're seeing here is that we're importing this. We're importing what's in here, which is this, and what it is it's a function called calculate, which subtracts 5 from the parameter. And so, and here's another function called calculate, which adds 5 to the parameter. And so what does this print out? Well, this prints out the result of this calculate, which is the subtracting of 5. And this one prints out the result of this one, which is adding 5. So the first one you put here is 3 minus 5 is minus 2. And then the next one is 3 plus 5, which is 8. You got to put the enter. See, so, all right, very simple. See, this has to do with built-in modules. And so these modules are built into the Python interpreter, and you don't have to have an associated .py file for it. And this talks about the places where it looks for .py files when you import, and you import and there's no .py file in the same directory. So then it starts looking in these other places, and that's what this is talking about. the places to look. Now here, this talks about importing the actual function names, and that way you don't have to put the module name in front of it. You don't have to put module name dot function name. You can just put function name. And to do that, you do it this way. You say from the module name, import, and these are the function names. So if you do it this way, import mymod, and you want to use this calc function, you have to say mymod.calc. Or if you do from mymod import calc, then all you got to do is say calc. See, so that's pretty good. All right. Hash library. All right, so anyway, that explains that. So we'll go through this, make sure you understand it. Executing modules as scripts. So here, executing modules as scripts. Oh, I see what they're talking about. So let's say you want to import web search. Web search. Okay. So let's say you have this program or this Python file, and this is it. And this Python file is actually a program called web search down here, because when you execute web search.py, this here executes. It asks for search terms and does this, and of course it's going to use, it's using these nice you know, functions that the person that wrote these functions and then wrote this code down here to use these functions. Now, let's say somebody else comes along and they would like to use these functions in their own program. They don't care about this down here. They just care about these functions up here. So this is a module called web search, and in somebody else's program, like here, you can say import web search. Okay, that's fine. So you import web search. The problem is once that statement executes, it actually just executes it. And what happens is this executes. Okay, so you just have this here, but then, you know, that causes this to execute, and then you're going, what the heck's going on? And so what you want to do is you want to make it so when this program, when this thing is running all by itself, in other words, the person types in Python web search.py, then yeah, you want this to execute. But when somebody is using web search.py as a module to import, then you don't want this main program stuff to execute. And to do this, you put the main program as a block to this if statement. So instead of so this web search.py that's got search defined, this defined, and this defined, instead of having this stuff right out, you know, here, you put it as the block of this if statement. Okay, so this is the same as this, except for it's inside this if block. Okay, so what is this if block? Well, I think it's something like, this is actually the name of your program, I'm not sure. You know what I'm gonna do? I'm gonna what's something we were just working on? Okay, well I'll get to that. Let's okay, reloading modules. Sometimes, but then the source code of the imported module needs to be changed since modules are executed only once. When imported, changing a module's source does not affect running. Instead of restarting the entire Python program, you can reload the function. Send. Okay, sure. Yeah, because this can change because it's importing. I guess when you need to use that, you'll know. I've never needed to use that. I've never used this. So this is interfacing to a mail server. All right, packages. Where are we here? Modules, and so this is so go through this. I can't really explain it any better, but this is where you bundle up some modules into packages and import those. Here's some labs, and see what labs should I do. So I'll do some labs now. This is a lab that's due. All right, I'll do one of these other ones. We have the main, okay, and then we have the artist.py module and artwork module. And in main, we've got this thing here. Okay, so let's see what this is. Define the artist class in artist.py with a constructor to initialize the artist's information. The constructor should by default initialize the artist's name to none and the years of birth and death to 0. Define an artwork class in artwork.py with the constructor to initialize the artwork's information. The constructor should by default initialize the title to none and the artist to use the artist's default constructor parameter values. Okay. So artwork has an artist property, I guess. Okay, so and this shows our, okay, so this is the main program, and what we need to do is fill in this. This is the constructor for the artist, and we need to fill in the constructor for artwork. Okay, so you know, I'm gonna see what happens when I just, what do I need to, oh, I need these inputs. 1, 2, 3, 4, 5 inputs. Okay, does it give me 5 inputs? Oh, here's 5 inputs. 1, 2, 3, 4, 5. So when I input this, it should output this. Okay, so let's just start with this, and it's not going to do anything because I haven't written any code yet. But I want to see what happens when I put this here right now, and I run it. What does it say? So inside main.py on line 10, which is here, inside there, it was trying to execute this thing. And there was a naming error. That was the exception that was raised. This is not defined. This is not defined. Oh, it's because we didn't even import anything. Okay, so let's import them. and we need to import, we need to use the from artist import artist thing. Okay, so I think it's got to be a from artist import artist, I think. From artist, import artist, yes. And from artwork, import, that's right. Import artwork. Now what happens when I run it? Okay, and the reason is because the constructor doesn't work. Okay, so I'm gonna find the right answer because I don't want to waste anybody's time. Let's go to modules. I'm doing this one, and when I go here, so the constructor for artist is, we're going to start out by saying def, and it's this underscore underscore init underscore underscore, and we always put a self, and then we're gonna put in some default values, and those default values are this is artist. Artist name is none, years of birth and death is 0. So we can say the name, yes, looks like this, lowercase, birth year, death year. Name equals none, and birth year equals 0, and death year equals 0. And so those are the defaults, and and then we're declaring 3 properties to store those values. Self dot name equals name, and this is the name of the property, and this is just this. So this can be anything, but it's got to be the same as this. But this is the actual name of the property. So this corresponds to this. And this is just the same as this, just out of convenience, so we can keep track. Okay, and then self dot birth year equals birth year. Again, this is the actual name of the property, but this is this. Self dot death year equals death. Okay, so that is a pretty good constructor. That's really all we need for the constructor. He thinks. For that, and then for the artwork, constructor would be okay. So here we have to import. We're gonna be using artist, and so we need to import that class because it's a data type we don't have. But so the constructor is define init, and we need a self, and we're setting the initial we're going to initialize title to none. We're going to initialize year to 0. And we're going to initialize artist to a default artist object. And so that's why we need to import the class. So we need to import from artist.py, import the class artist. Okay, so that's this. From this module, import this class. So and so we're going to create an instance of artist, and we're just going to use the default constructor. And we're doing that in artwork. So here, the title is going to equal none. And the year created is going to equal 0. And the artist is going to equal an artist object with default parameters. So it's like this, equals a default artist object. Oops. So that's the so those are the defaults as they come in, and then we have to actually declare the properties. Self.title equals title. That again, that's and self.year created equals year created, and artist self.artist equals artist. And the reason you don't just say none here and 0 here and 0 here is because these actually might be defined as something else. You know, these are parameters, and so title, if when these are called title is specified, then it's not going to be none. It's going to be what it's specified. If the year is specified, the year was created was specified, it's going to be that year. It's not going to be 0. But if they're not specified, that's when these defaults are used. All right, I think that might be it for this. So I'm going to go back and see what happens when this is used. Oops, that's wrong. So that is in the, let's look at this. This is in artist.py. It's the syntax. It's telling me the syntax is wrong. This doesn't make sense. This should be an equal sign, obviously. But it's in artist.py in line 4, but it was called from main.py line 2. It was trying to execute this. In other words, it was trying to execute this, and so it goes down to and finds this, and it says in line 4, which is right here, there's a minus sign. It should be an equal sign. So let's fix that and go back and run it again. Yeah, look at that. Is that what it should be? I'm sure it is. Now, so this is probably it. I'm going to just try to submit it and see what happens. Yeah, that's right. Since you aren't getting any points for this. Okay, so that's that. Now, I tell you, what I did want to do is I wanted to see exactly what, I wanted to see what this was. Okay, I think this is just going to say main. In fact, let's print name, say, well, I can say equals that. Sorry. Equals. All right, I just want to see what that is. Submit for grading. I shouldn't be submitting for grading. I should be develop mode. Run the program. Okay, yes, of course it's that. Now, I want to take this and I'm going to put it in here, and I'm going to put it down here. So when, okay, so that's there, and now when this is executed, we should see this thing print. Okay, so, and I want to see what it is. Okay, so I'm going to get rid of this one because I don't need this one anymore. And let me run this. Artist. Okay, so that was inside here. So this is equal to artist. So what I should do is, well, I don't need to, but so name, so when this thing executes inside here, name is equal to artist. I'm sure it's the same thing when it's in here. If I do that, name is going to be equal to artwork. Oh, I wonder if it's going to execute. It might execute artist again. See, look, because it executes this here, but then when this thing executes, then this executes again. So we should see this thing here execute twice. All right, so I'm going to run it and see if that happens. No, it didn't. I think there's something where since it already executed once, it doesn't execute again. And let's use the reload thing. All right. Anyway, so that's this. What time is it? It's 4:08. Why don't I, to make this a little bit more worthwhile, why don't I start this one? So that's dates. So we're supposed to I want to see how long the solution is. There's only just one solution. We're supposed to, ooh, we have a lot to do here. Okay, we have to plug something in. I'll plug something in here. Okay, first of all, complete the code to implement the following operations. Complete read date. Here, complete read date. Okay. All right, complete read date. So you read an input string that looks like that, and we create a date object from the string, and we return the date object. Okay, so So we have a date object, read date, and I guess to create a date object, well, I'm just going to do it here for you. I'll just put start right here, and I want to input the date. So I'm going to say in date equals input. So enter the date, and then split I guess split the date. Year, month, it's a list. Year, month, day is equal to split. Oh, I'm sorry. In date, split on a hyphen. How am I reading this in? So this is a SQL format. So split on that hyphen. And creating a date object is just open this link. Date. Okay, so this is the date object. This is the year, the month, and the day. So that's the date object. So let me go back to here. And so we've got that. And so we're going to return. Okay, so I'm just going to say date obj is equal to date, because I'm using this thing right here. And I don't need to put that there. So I'm just going to say date of, and it's got to be numbers. So integer of year, integer of month, integer of day. Okay, so that's a date object, and then that's what I'm going to return. Return date object. Okay, so that reads the date object and returns it. And now I'm going to say use read date to read 4 unique date objects, putting the date objects into a list. Okay, so well, I'm going to call it, I guess I'm going to say dates. The list is called dates. So I'm going to say D1 equals read date. D2 equals read date. D3 equals read date. How many? 4? 1, 2, 3, 4. D4 equals read date. So I'm going to get through one here, then I'll end this. Oh. Could you explain how to use the formula in 11.3? Okay. Yeah, let me finish this and then I can show you that. Is this something? Okay. All right, let me just finish this. And then I'm going to say, I'm going to create a list. So I guess I can just do this. Dates equals D1, D2, D3, D4. And then I can sort. Use sorted to sort the dates. Dates sorted. Is this going to work? Let's see what I'm going to do. All right. Sorted dates equals sorted dates. And this in ascending order. And now let me print the dates with that format. So I guess I can do this is how you do day, month, year. Day, month, year. This is month, day, year. Okay, so lowercase. Okay, so if we want to output this, we can say for date in sorted dates. I better not use date. I better use date 1. For date 1 in sorted dates, print date 1 dot, and I'm going to use this string f time. So let me just copy this. Copy that, but I want it to be month, day, year. So I want it to be month, day, year. So let me print this. And let me run this. Really? Oh. All right. So unexpected end of file while parsing. Well, that can only be because it didn't expect an end to the program because it was still looking for something. Okay, and what it was looking for is it found the right parentheses for this left parentheses, but it did not find the right parentheses for this one. So it kept on looking all the way down to the bottom and it never found it. So that's why it said an unexpected end of file while parsing. It's parsing along. It's looking for the right parentheses to match this left parentheses, and it's still looking, gets to the end of file, and so that's unexpected. So to fix it, I just have to put that there. And now it should run. And I got a value error because when I was defining this date object, it's apparently not an integer. I wonder what's wrong with this. That is up.
In your input box, you put D4, the last day.
I did in my input box.
No, where you enter the program, the below run program button,
The
the yellow button.
what? The where?
The yellow button, run program.
Yeah. Oh. Right. I see. Yep. Yeah. This is to me this is orange. So sorry. That's why I didn't get it. Okay. So I delete that. That's what you meant, right? Okay. Good. Okay. All right. Good. So is that right? No. No, it's not. That's not right. They must mean capital Y. Okay, there. So that's right. Now you can continue, and you need to do output the number of days between the last two dates in the sorted list. Well, you can so you can take the last two would be D3 and D4, right? So you can do difference equals D3 minus D4, and but if D3 is smaller than D4, if D3 is earlier than D4, then this is going to be a negative number. So we want to do the absolute value of these, absolute value of D3 minus D4. And then we want to display out the difference. So that's going to be the difference in days. Take 1 day minus, and apparently you can do this in Python. And so now we want to display out the difference in the days as days. So print difference dot days. Really? Okay, well, let's see what this does. $575, is that what this? 25. And I said 575. Oh, it's sorted. So it's not D3 and D4, it's sorted. It is, the difference is D1 equals sorted dates of the last two, right? So it's going to be 0, 1, 2, and D2 equals sorted dates of 3. So this is the second of the last one, and this is the last one. And then I want to take the difference between D1 and D2. Okay, those are the last two dates. And yes, that's 25. Okay, the last two dates. So there's 25 days difference between those last two dates. All right, so that's what that one is. And then Well, I'm going to let you work on those two, the last two. But the last one is, or this one is, output the date that is 3 weeks from the most recent date in this format. The most recent date would be the one at the bottom. And then you want to go 3 weeks. So the most recent date is going to be this one, sorted dates 3. That's the most recent. And then you want to go, you want to add 21 days to that. So anyway, and then examples of using date objects. Let's see if I got to find an example to help you. Time delta objects. Is this described somewhere? This is really out of this world, man. Time delta. You have to use the time delta function for number 6, and it's not here. All right. Well, anyway, why don't you work on? Did I just get rid of my stuff? Okay, anyway, all right, well, I'll come back to 6 and 7, but I'd like to figure out some way to give you more information that you need, like the functions and so on, and then how to format the output. I'd like to give you that information, and then you put together how to take those functions and add 21 days to it. You can maybe search the web for that. All right, so it's way past, but Terrell asked a question, 11.13, the formula in, okay, so let's look at that. Is that, oh, this one, the next one, this one. Ah, this, okay, so, yeah, that's a good one. Let me see what this looks like. All right, sure. Okay, so and we would put that here. Okay, so here we're supposed to compute this. Compute the, which formula is that? This one. This one? Yeah. Okay, so all right, so I need to write this down, and I need to have this in a place where I can read it. So I'm gonna just open up something. Okay, let me this is a different class. Let me open up a text, some sort of texty thing, and I want to this formula first. NT is what we're computing. Compute NT, and we need the parameter this, and this. It is N0, E, and T. And is that, boy, I can't hardly read that. minus 0.693 t, little t over big T. Well, this is big T. Okay, well, E is Euler's number. Oh, accessible as math.e. So let's do this. Let's do compute nt. Let me just copy this. Okay, so we're doing these two things. I'm just going to copy this here. And so I'm going to go compute nt here. That is going to be n initial amount of the isotope. So that's this. So I'm going to say nt equals the initial amount of the isotope, which is N0, yes, N0, times E, N0 times E, which is Euler's number accessed by it. So math.E, and then it's to this power. And that power is it looks like it's minus 0.693 times t, length of time in years. Oh, this t times that little t. Okay, that thing. Actually, it's not going to do. Well, actually, I don't need to. I could just divide it by the big T. That's this big T. Okay, divided by the big T. Okay, so this minus 0.693 times little t divided by big T is this thing here. And you can do it this way. You don't need to put parentheses around the top part, but you can if it makes it more clear. And so this is the minus 0.693 small t divided by big T, and that's the power that you raise E to, and that works like this. That's how E is used. You raise E to the some sort of power. So that's what this math function is here, and you multiply that by n naught or n0, and that's this nt, and that's what you're going to return nt. So that's the first one. And then we need to do this one. So I'm just going to say t equals, what is it? It's 0.693, must be something special about that number, times little t, divided by the natural log. How do you get at the natural log? Math ln? Oh, just math log. Well, let's do some parentheses here just to make it more clear. So it's this. This is the top. This is the numerator. Divided by the denominator, which is going to be math log. It's just log. I wonder how it knows it's natural log. And this is of nt, which is this thing. Nt divided by n of n0, divided by this one. So this is this. This is the numerator. You actually don't really need to put the parentheses there because multiplication is, it'll do the multiplication first, then it'll do the division, which is what you want. And this natural log of n sub t over n sub 0, or nt over n naught, is this nt over n naught, and then it's the natural log of it. And I guess that's what log is. And then that's what you want to return. You want to return t. Okay. And so these are the two. So this function is this one. And this other one here is this one. And I can do, I'll do the, let's see. All right, I'll do n, okay? I'll do n. So we're supposed to input n0, nt, and big T from one line of input, and we're supposed to compute, we're supposed to call this function and output. Okay, so does it give us some sample output? Yeah, I guess it does. So it's going to give us this n output. This is what the input and this is what the output should be. So I'll do that one. You can do the other two. All right, so it's going to be, I'm going to read, and they want it to be all in one line. All right, so I'm going to say input inline equals input, and I'm going to say n0 comma, do I got to put parentheses in? N0 is the first one that comes in, t, small t is the next one that comes in, and capital T is the third one that comes in. And we can do this in Python because it's a lowercase letter is different than an uppercase letter. It's not that way in all languages, but in most languages it is. And that's going to be inline split on a space, so we don't put that there. So now we've got n0, t, little t, and big T, and we want to compute nt, it looks like. So we're going to use this function. We're going to say nt. Oh, I got to convert these to something. I got to convert these. N0 equals float N0. And I say lowercase t equals float lowercase t. You guys are still hanging out here. And uppercase T equals float uppercase T. And now we've got the 3, and now we can do nt equals compute this thing. And then we print it out right here with 4 digits to the right of the decimal point. And so I'm gonna just see what this looks like with these compute n. Yeah, okay. So that's what the input is. And let's see what it looks like when it runs. Okay, so float object is not called. I'm doing something wrong. Okay, so on line 8 in compute T, I'm doing something is wrong with this. Gee, I don't know what's the matter. compute NT and 0T colon. I don't see that this should make a difference, but if this doesn't make a difference, I'm going to have to explain that. Okay, I see my error. It's this E here. It should be EXP. I was looking at this E, but the actual math function is EXP. And so that looks better. Let me see what this looks like now. Run the program. And yes, that's much better. So it output the NT equals this. All right, so I hope this helps. Thanks for watching.